Applications of linked lists. Linked lists find application in various scenarios due to their dynamic nature and efficient insertion and deletion. Some common applications include dynamic memory allocation. Linked lists are often used for dynamic memory allocation, where the size of the data structure is not known in advance, and memory needs to be allocated or deallocated during runtime. Implementation of data structures. Linked lists serve as the foundation for implementing data structures such as tags, queues, dequeues, and symbolic expressions. Undo mechanisms. In applications that require undo mechanisms, linked lists can be used to keep the track of state changes. Each node represents a state, and traversing backwards allows the undoing operations. In the file systems, linked lists are employed to maintain the directory structures. Each node represents a file or directory, and the links connect the hierarchical structure. Task scheduling. Operating systems often use the linked list to manage processes in queue, where each node represents a process and links determines the order of execution. Music playlists. Linked lists can be used to implement playlists in music applications. Each node represents a song and links determine the order of playback. Linked lists are used in adjacency list representation of graphs. Each node represents a vertex and links connect vertices that share an edge. Hash tables. Separate chaining in hash tables often involves using linked lists to handle collisions. Each bucket in the hash table can be a linked list of elements that hash to the same index. Simulation of real world objects. Linked lists can be used to simulate real world objects and their relationships. For example, modeling a train with each car represented by a node, linked together in sequence. Polynomial representation. Linked lists are used to represent polynomials where each node contains a term of the polynomial, and links connect the terms in the proper order. Symbol table in compilers. Compilers use linked lists to implement symbol tables. Each node represents a symbol, and the links connect symbols based on their scope and references. Network routing algorithms. In networking, linked lists can be used to represent routes. Each node represents a router, and the links represents the connection between routers. These are just few examples, and versatility of linked list makes them suitable for wide range of applications where dynamic data structures and efficient insertion deletions are essential.